this lecture we will see what is algorithm, and we will try to complete discuss of design and analysis of algorithm. First we need to think or give answer what is an algorithm. What is an algorithm? Algorithm is a combination of sequence of finite steps to solve any problem. Mark these words, that combination, sequence and finite step. What is the meaning of combination, sequence and finite step? We will see these using an example. Take example of two number, addition of two number. First we need to take two number, then add these two number and store in some variable and then print value. This is the combination to add two number. We are not able to we can't left out any one statement from this combination, because without taking any two number, which number we will add? So take two number is necessary, then we need to add those two number and store in C, and after that we will print. Now this is the combination for addition of two number. Now sequence is also required, that we can't switch one or two statement, one statement to two second number statement and third statement to one statement. That this sequence is also required, that order of the statement are also required. This is the sequence. And algorithm should always terminate after finite number of steps. That finite number of steps can be 1000 or any number, but should be in constant number. After that constant number, the algorithm should be terminated. Okay, this is the combination, that we can't left out any one statement from this algorithm, and the order is also required, that is sequence. And after a finite step, that this algorithm is terminating after 3 steps. On the same way, every algorithm should be terminated after finite step. Now every program is an algorithm? Actually it's not true. Take this example, that this is a program, but it's not an algorithm. Why? There is a combination, yes, only one statement. Sequence, okay, so we will do something and then print it, okay, but this statement, this program will never terminate. So there is only one statement, finite number of statement, but it is not terminating. So now we will see properties of algorithm. Properties. Algorithm first property is that it should terminate after finite number of time. After finite time, it should terminate. Next, it should produce at least one output. If it is not producing any output, why will write any algorithm or any program? If you know that it's not anything, not producing any answer, then why we will go ahead to do that work? On the same way, if an algorithm is not producing anything, then why we will write that algorithm? Okay, now it should take 0 or more input. Next, it should be deterministic or unambiguous. Deterministic in the meaning that if we give same input again and again, output should be produced same. That we all know, 10 plus 10 equal to 20. If we add a and b equal to z, then if we take a equal to 10 and b equal to 10, then z should always be 20. On the same manner, algorithm should be deterministic, that it output should be same as we give same input, and algorithm should be unambiguous. Unambiguous means the output should not be produced same for different input. If we give a equal to 20 and b equal to 20, then it produces 40 for a plus b equal to z. If we write some algorithm which is producing same output for the different input, then this algorithm is there is some ambiguity problem. So this is not acceptable for an algorithm. Next, it should be independent of programming language. That an algorithm is not saying that I will develop only using C and I will develop only using Java. This is not acceptable. The algorithm should be independent of programming language. Okay, now we will see the step to develop an algorithm, or step to required to design an algorithm. First, problem definition. If we are clearly about what is the problem, or clearly know the problem definition, then 50% algorithm development is end. Now we need to work on only 50%. Knowing problem clearly is the major problem. If we get the problem definition, then 50% work is over. Thereafter we need to design an algorithm. It's very crucial that actually designing an algorithm is not we start from scratch. We have some algorithm given. We need to select one and go ahead according to our problem. That we have template, and selecting appropriate template according to our requirement and fill the content. This is the designing of algorithm. Designing an algorithm is nothing. Designing algorithm is not we need to develop from starting. That we have a lots of template, or we have a lots of algorithm developed previously. We need to select one according to our requirement. For example, divide and conquer, greedy technique, dynamic programming, backtracking, branch and bound, according to our requirement. Okay, remember this statement that designing an algorithm does not mean design algorithm from starting. It has developed previously. Only we have to select suitable. Or designing an algorithm is nothing but in the existing algorithm, which one is suitable, select one. This is the designing of algorithm. Now in third step we will draw flowchart. Yes, after designing an algorithm 80% work is over. First 50, then now 80% work is over. Now draw flowchart. What is flowchart? If we write algorithm, if we write the algorithm in form of a diagram, that is called flowchart. When we develop flowchart or draw flowchart, overall 90% work is finished. Okay, now we need to test our algorithm. For different input we will find what will be the output, and there 100% algorithm is developed. Now thereafter we need to analyze the algorithm. For analysis we will use time complexity and space complexity. Now we will go to develop that algorithm. Use any programming language to develop that program. Now what is the time complexity? Time complexity of a program. So TA is representing that time complexity of a program A. Time complexity of a program is nothing, it's compile time of program A and run time of program A. Now compile time is depend upon software, that which language is used to develop that program, and run time is depend upon processor or hardware. Actually if we see that Pentium dual core PDC compile time is higher than core 3. That PDC has only 3 MB of cache. On the other hand, in core 3 there is 4 MB of cache or more difference. This is an example that why PDC is less faster than core i3 core 3 or core i3. Now analysis is also two type, that is post-tree analysis and prior analysis. Post-tree analysis depend upon which language is used to design the compiler, which type of hardware is used, and post-tree analysis give exact answer, and system to system it will different answer. Prior analysis is independent of language of compiler, independent upon type of hardware used. It will give approximate analysis and same answer in each system. Okay, according to post-tree analysis algorithm taking less time, credit will goes to CPU plus compiler language. But according to Pyre analysis algorithm taking less time, credit will goes to programmer. That programmer sit any good or maybe best logic to develop that algorithm. Okay, now Pyre analysis. Complete software industry follow a Pyre analysis. According to a Pyre analysis, what is time complexity? Time complexity is nothing but it is determination of order of magnitude. Mark this word, order of magnitude of a statement. Order of magnitude of a statement. Order of magnitude of a statement. Number of time an statement is executed, that is order of magnitude. Number of time in a statement is execute or run is order of magnitude. Mark this word, that order of magnitude. Time complexity is nothing but it is determination of order of magnitude of a statement. While running a statement will execute how many times is called order of magnitude. Take an example, main. Okay, this statement will execute only one time. There is only one statement which will execute only one time, so its time complexities will be theta of 1. Okay, while running a statement will execute how many times is called order of magnitude of a statement. Now there is only one statement. Number of times this statement execute or run equal to 1, equal to order of magnitude. Okay, this statement will execute only one time. This is the order of magnitude of this statement, and time complexity will be theta of 1. Okay, thank you.